As your projects grow, you'll face problems like where to put functions and variables, how to send data and function calls between classes, and how to extend logic without breaking everything else while avoiding duplicate code. These issues are solved by the 4 pillars of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. They help keep your code organized, modular, and easier to scale as your project gets bigger. Encapsulation refers to bundling data and related logic and modifying the data through bundled functions. Here we have an example of code that doesn't use encapsulation. The enemy modifies the player's health directly without using a function, and the game manager is storing some data, which should be stored in the player. Now, with encapsulation, all the player's variables are stored only in the player, and if other code wants to modify them, instead of directly changing the health in the attack function, the enemy calls the player take damage function, which does the same thing, but it keeps the code decoupled. You can add changes to the variables or add extra logic without having to go through and modify a bunch of code outside of the player class. Another thing to keep in mind is that when you're using encapsulation, for variables that you want to be accessed outside of the class, a good example is configuration variables. For example, starting health would be most likely set once in the beginning of the game or in the inspector. It's best for it to be accessible by other classes, so a public variable. And private variables, on the other hand, are variables that should only be modified by the class itself. Like here we have health and player score, which are only modified by the player. And to differentiate between them, private variables should have an underscore in front of their name, like so, and public variables just have nothing in the beginning. The underscore doesn't prevent you from modifying private variables or accessing them outside of the classes. It's just a hint for you to know that you shouldn't be doing it. So in general, don't access private variables outside of the class, but for debugging, you could still access it to see what's going on. Now, the benefits of using encapsulation is that only the player changes its variables, so you could easily keep track of how each variable is being modified and swap out logic across all the classes that modify the variable by just changing the take damage function. It also makes sure that any side effects of the take damage function are always run, like printing the player has been defeated if their health reaches 0. Maybe play some animation or play some sounds when the player takes damage. Now, the next pillar of object-oriented programming is abstraction. It refers to hiding the details of the code inside a class while exposing only clear high-level actions. Here's an example. We have this inventory system here, and the low-level details are how the items list is being modified. And the high-level abstraction is add item and remove item. This allows you to reason in terms of these actions, instead of being concerned about the background details of how the items list is being modified every time you need to add or remove an item. Without abstraction, imagine you have a bunch of classes like UI, enemy, shop, quest system, and they all want to modify the player's items. Without abstraction, to do that, you would have to directly modify the player's items list, and it will become really difficult to expand on this behavior. Here, for example, we have some logic that makes sure that there's at most 20 items. What if we wanted to add different types of inventories? So we could be able to specify the category of an item, and only items of the correct category could be added to this inventory. With abstraction, we could easily add some extra logic here to check the item's category. But without abstraction, we would have to add the same logic to all of these classes. That'll greatly complicate your code and increase the likelihood of bugs. With abstraction, all these classes would just call the add or remove function instead of modifying the items list directly and having to run all this additional logic. If you're a bit confused between encapsulation and abstraction, so for encapsulation, having a function like set health instead of modifying the health variable directly is still encapsulation. But abstraction requires something more higher level, like take damage. Because you're not just setting the health. If an enemy attacks a player, it's performing a specific action. It's not just reaching out and just changing a variable. Now, the benefits of abstraction is simpler code. Instead of having to perform this list of actions, every time you want to do a common action, you could just call the function. in the same class and in other classes. And it allows you to decouple classes. In this example, where everything directly writes to the player's items, this code is really tightly coupled. So any changes to the logic or the player item's variable makes the relation between all these classes. Instead of being able to change something about the player, every class has to receive that change as well. But with abstraction, this is no longer an issue because the changes are only required in the player and they take effect immediately across all of these other classes. Now, the next pillar of object-oriented programming is inheritance. It refers to reusing shared code by building on existing classes and only adding or overriding what's different. Here's an example without inheritance. So we have an enemy and a player, and they both have a bunch of variables and a function. All this code is shared. So the speed, the health, the take damage. And we could reduce duplication of this code by abstracting it away into a shared player class. Now, with inheritance, the variables and the function are shared across the enemy and the player. So we could add new changes to the take damage function, for example, and it will immediately take effect. You could also extend logic. In the player class, let's say we want to turn the screen red if the player dies. We can do that by using this super keyword to call the function from the parent class, and then add some extra logic, turning the screen red. We could also easily create new classes, like an NPC class, and add a new function. So this NPC only has extra code for the talk function, but because it's a character, it receives all the code from the character for free. The benefits of this is that you'll obviously reuse code. You could override only the differences, and it'll keep logic more organized. Now, the next pillar of object-oriented programming is polymorphism. It refers to using a common interface for different types, with each type defining its own behavior. Without polymorphism, your code would look something like this. We have a bunch of objects, and we want them to take a turn. For the player, we call handle input to get the user's input. And for the enemy, we use some AI logic to make a decision on its next move. Without polymorphism, we would have to check the type of the object to determine which function to call. And with polymorphism, the code is greatly simplified. We could just call take turn on the character. It will automatically pick which function to run. For the player, it'll run the handle input function, and for the enemy, it'll run the AI function. This example uses inheritance, but inheritance is not required. In GDScript, even if these classes are not inheriting the same class, you can still call this function, as long as its name matches exactly. The benefits of polymorphism is that you could use the same function call, but override it and get different behavior as a result. You could easily extend the code to include new types. Like if we added a NPC character right here, it would still use the same take turn interface, but have a different behavior specific for the NPC. It results in more organized code. In the without polymorphism example, you have to parse through this code to determine what it's doing. But here, it's much clearer what's going on. Each character is just taking a turn. And you don't have to think too much about the actual logic. Just to recap, here are the 4 pillars of object-oriented programming. We have encapsulation. So we have a bunch of data, and instead of having it scattered throughout the code, we just put it in the player. And we modify it through the bundled functions in the player. So it's easier to keep track of who the data actually belongs to and how it's being modified. Abstraction refers to hiding details and exposing clear high-level actions. So for an inventory system, let's say we have a list. Instead of modifying this list directly, we could use add item and remove item functions, which then add or remove items from the list. This will allow you to change the details without having to change other classes as well, and will result in cleaner code because the actual logic for modifying the inventory will be only in the inventory. You wouldn't have to duplicate it across classes every time you want to add or remove an item. You just call the function. For inheritance, reuse shared code across classes and only override what's different. So if you have some duplicate code or variables, abstract it away into a shared class and only override the differences. This will obviously reduce the amount of code you have and keep your logic simpler. And make sure that any changes take effect across many different classes. The last pillar is polymorphism. It refers to different classes have the same function, which can be called as we had with the game manager. So you can call all these functions without having to do the check for the type of the class. This will allow you to easily iterate over a bunch of classes, or to swap them in and out, or add new classes without maintaining this whole list of if statements. If you want to learn how to design scalable architecture, write cleaner code, and make development easier as your games grow, check out my full course. You'll learn how to structure your projects, reduce bugs, and make your codebase easier to expand. Link in the description.